Hi, welcome to actually my very first, now that I think about it, Q&BA live video chat session, where you guys get to ask me questions. So instead of Q&A, it's me, the bad astronomer, Q&BA. See, it's a joke. It's the best I can do. I'm really excited to be able to do this using Google Plus Hangouts on Air. Google Plus Hangouts are wonderful. It's a way of video chatting with your friends, but now they have something called Hangouts on Air, which allows you to broadcast this, and so anybody can join in. You can watch, and there's an unlimited number. So what's going to happen here is I'm going to make a few announcements, just a few things to let you know what's going on. I'll introduce myself for those of you who don't know who I am, and then I'll take questions in the stream on Google+. So if you go to my post on Google+, which I've just tweeted as a matter of fact, I am at Bad Astronomer. You can find, of course, now that I'm thinking about it, if I'm saying it here, you probably already know about that. So a little bit of a inception thing going on there, but I won't worry about it. You can ask me questions in the post with the stream on Google+, or on Twitter, where I will be checking every few minutes. There it is. It looks like people are here in Twitter. Yep. And people are here on my stream in Google+. And the problem here, now I'll mention this, is that I have to refresh the post I made where this is embedded. So that is on Google+. So to be able to see your questions when you write something, I won't see it until I refresh, and then I'm going to have to scroll all the way down. This is live, so there's going to be a little bit of hiccuping and stuff, with me having to do things, but hopefully this will all work out. I see some questions already coming in, so give me just a moment, and just to, let you guys know who I am. My name is Phil Plait. I am an astronomer. I am a blogger. I write the Bad Astronomy blog for Discover Magazine. I've written a couple of books. Death from the Skies is the most recent one, another one called Bad Astronomy. Death from the Skies is all about the ways I could think of to have the universe try to kill us. Asteroid impacts, solar flares, and that sort of thing. Bad Astronomy is just about myths and misconceptions that people have in astronomy. I've written a lot of other stuff, and I've done some TV work as well. I was the host of Phil Plait's Bad Universe, which was a science documentary miniseries on Discovery Channel. I've done a lot of talking head stuff on TV shows, like the most recent one is How the Universe Works. I heard that was on Science Channel this morning. I got some tweets about that, people saying, hey, you're on TV. That's always fun to see those repeats showing up. How the Universe Works actually has a second season that has been or is being filmed. I think it's already been filmed in post-production, and it'll be airing later this year, I think in the summer. And I'll be on that as well. As a matter of fact, I think I'll be in all 6 episodes. We went all over the place filming that, and it was a lot of fun. Let's see. So you can find me at badastronomy.com. That's my website. That will take you directly to my blog on Discover Magazine, and there are links in the sidebar that will take you to my old website where you can find movie reviews and things like that. And that's me. And a couple of things I want to let you guys know about that are coming up. I will be... and let's see, how do I do this? I don't think I can put these in the post without a lot of trouble, so I'll just tell you about this. If you live in the Pueblo, Colorado area, I will be giving a talk there on Wednesday at, I believe, 7 o'clock, something like that. It's free to the public, so if you live in southern Colorado, northern New Mexico, that sort of area, come and see me. It's going to be at CSU Pueblo at Colorado State University. I have up on my blog an announcement about that. I think that was up yesterday. So I'd like for everybody to just show up to that. I'll also be, this is what's coming up in the next couple of weeks. George Hrab, my friend who's a musician and a skeptic and does the Geologic podcast, is having a concert called 21812. If you look up that on the web, it's HRAB 21812. You'll see that he's having a music concert in Bethlehem, Pennsylvania on February 18th, 2012. That's why it's 21812. And I'll be there. I'll be on stage. He has a song called Death from the Skies where I actually talk a little bit about the odds of different astronomical events wiping us out. And that's a pretty fun song. I love doing that with George. I've done it a couple of times. It's on his latest album, and Trebuchet, and it's a lot of fun. So if you can go to that, that's going to be awesome. I can't wait to do that. Let's see. Those are, I just had a couple of announcements, so that's it. I will make this window a little bit smaller so that I can see you guys better. I want to make sure I'm looking into the camera and not at me on my screen because that looks funny, doesn't it? Ooh, I look like some Russian mad scientist from 1950s Soviet movie. All right, awesome. Now, the whole point of this is to answer questions. I love doing this. One of my favorite things when I give public lectures, and I do give public lectures, send me email, is the Q&A afterwards. And I love it, especially when kids ask questions, because they're very enthusiastic and they're shy. And you go, oh, I read about this, and I love being able to do that sort of thing. So let me refresh the post. Oh, another announcement. If you are actually signed up for Google Plus, and I highly recommend you do, I post there all the time, different stuff than on Twitter and different stuff than on my blog. Sometimes I follow a lot of photographers on Google Plus and a lot of other folks there, and I will reshare things there that I won't necessarily put on other social networks or the blog. So you should really join up and circle me there. And also because every Thursday, I knew there'd be another announcement, every Thursday, Fraser Cain runs an astronomy space roundup where Fraser and me, Pamela Gay, Emily Lakdawala, Alan Boyle, Ian O'Neill, John Voisey, a lot of science journalists and scientists, we sort of wrap up the news that's happened over the week, and it's done just like this. And finally, when this is all done, it's going up on YouTube. That'll be up later today, probably in the evening. It's going to take me a while to edit it. So you should join Google Plus, and the reason I brought that up, I get so distracted by my own blathering, is that you can +1 it. You'll see at the top of this post, under the YouTube embedded video player, is a little button on the left that says +1. And if you +1 it, then I know how many people are in here and how popular this is, and that helps me a lot to figure out if this is worth doing. And then I do it anyway, even if there are only 5 people in here, because I love this so much. All right. Oh, we have somebody in Germany. That's cool. Yeah, you know what? If you ask a question, let me know where you are. And that way I can say, oh, look, this one's from, McMurdo Sound in Antarctica. That'd be cool, wouldn't it? Let's see. So I'm rolling down, and Jason Anderson says, and I haven't read this yet, so let's see. Hopefully, nobody will ask me a question I can't answer. If dark matter is pervasive throughout galaxies and clusters of galaxies, why can't we detect its effect on smaller scales, such as solar systems in the immediate solar neighborhood? That is an excellent question. This is true for a lot of things in the universe. There are forces that work on different scales, and there are forces that work on different amounts of material. So gravity works on everything. And, I have gravity, you have gravity, the Earth has gravity, the Milky Way galaxy has gravity. In this case, the scale of that is infinity. Gravity is a force that works forever. It affects every object in the universe. But the amount of gravity you feel depends on how much stuff is there. So, for example, the Milky Way galaxy has a huge amount of mass. It has roughly 400 or 200 or 100, very roughly, hundreds of billions of times the mass of the sun. And the sun has a lot more mass than I do, unless I keep eating my wife's cookies. She makes amazing cookies. And my mass is increasing without bounds in that case. But, you see, the Milky Way, look, I've got a Milky Way model. I love this. I love being able to use this. This is 3 DVDs glued together and a red rubber ball sliced in half and glued on top of it, and then a picture of the Milky Way put in the middle. So this is my Milky Way model. This is huge, and I'm little. And the amount of gravity, the amount of force that something has, depends on its mass. And it's the same is true for dark matter. Dark matter apparently doesn't emit light the way normal matter does. I'm emitting infrared light, which you can't see, but I'm also reflecting the light from these lamps in my window over here, so you can see me. The sun emits light, and you can see it. Normal matter does that. Dark matter doesn't, and so we can't see it, but it has mass. The thing is, its mass is very, very low density. So, if I had a cubic, there's probably dark matter everywhere in the universe. In some places, it's clumped more than in others. But if I were to randomly take a cubic centimeter or cubic whatever of space and say how much dark matter is in here, there's not a whole lot. Just like in general, there's not a whole lot of normal matter in space. So even over our solar system, there's just not a lot of dark matter. So it doesn't have much of an effect. Whereas over our solar system, there's the Sun, there's Jupiter, there's the Earth. Now, the Earth doesn't affect Neptune very much because Neptune's very far away, just like Neptune doesn't affect us very much. But over bigger and bigger scales, if I go out a light year, the Sun's effect isn't very big because now the Sun's really far away. But the bigger I get, the more dark matter is going to be nearby. And so as on bigger and bigger scales, dark matter has more and more of an effect. So on the solar system, on you, dark matter, not a big deal. But on something like a galaxy, which is, to make sure my scale's right, millions of times bigger than our solar system, at least, dark matter starts to have a more profound influence. So it affects how galaxies rotate. It affects how galaxies and clusters move around each other. But on the small scale, not a big deal. And that's that. Oh, there we go. Sorry about that. The video had frozen for a second. And I do apologize for starting late. I have to apologize twice for getting the time wrong. As somebody pointed out on Google+, I announced it as being 1800 Universal Time coordinated, which is sort of like Greenwich Mean Time. That's because I was thinking it's 1 o'clock Mountain Time. I live in Boulder, which is 3 o'clock Eastern Time. And I'll convert that to UTC. They're 5 hours behind, and 3 plus 5 is 8, so it's 1800. No. 3 o'clock Eastern Time is 1500 in a 24-hour clock. And then you add 5 hours, so it's 20 UTC. And I just screwed that up, just messed up the conversion. I apologize for that. That happens to me sometimes. It makes me crazy that our clocks are base 12. They should really be metric, but what are you going to do? And my second apology is starting a few minutes late. I had a little bit of trouble getting the camera working. That's going to happen, every now and again. It's live, so there you go. So Ronan Kazan, apparently a Doctor Who fan, asks, judging by the avatar, "Hey Phil, what is the most mysterious thing in the universe in your opinion, and what is the most interesting planet we should go to in the near future?" The most mysterious thing in the universe is dark energy. I think if you ask any astronomer, that's probably going to be their answer, if not dark matter. The thing is, a lot of people don't want to believe in dark matter. I don't like using that word believe because it's not a matter of faith. The reason we know dark matter is out there is because when we look at a galaxy, for example, that's rotating. The stars are make sure I do this in the right direction. The stars are moving around the center of the galaxy like that. They take hundreds of millions of years to go around once. But if that galaxy, if we're observing it, and some stars are moving toward us and some are moving away from us, we can see that effect in the spectrum. We break up the light into individual colors. And if the galaxy is rotating, and part of it's moving toward us and part of it's moving away from us as it's rotating, that affects the spectrum. We get a Doppler shift, and we can measure that. In fact, you can measure it fairly accurately. And you can calculate not just the rotation of the galaxy overall, but you can see that parts near the center are going around faster, parts near the edge are going around more slowly, or at least they take longer to go around. And the thing is, in a solar system, we know how that should work because we know how gravity works really well. The closer you are to the sun, the faster you go around. The farther you are, right, the longer it takes to go around once. And that's just 1 over r squared. And it's just a very simple, straightforward law that we've known for literally centuries. In galaxies, it's a little more complicated. But even then, what they found when they were looking at galaxies, and this is now decades ago, galaxies were not rotating the way they were expected. It was almost as if these galaxies were embedded in a cloud of matter that we couldn't see, and that was affecting the gravity overall of the galaxy. And it turns out that the same thing was true of galaxy clusters. When you have hundreds of galaxies like this, or thousands, living in a cluster like bees in a beehive, they're all moving around, and you can calculate how fast they're moving. When you add up all the gravity you expect in that cluster, because if the galaxies aren't flying apart, then that means the gravity of all the galaxies together is enough to hold that cluster together just by gravity. And if you calculate how much gravity you expect, those galaxies are moving way too fast. They should just whoosh, all fly off. But they don't, clearly, because they're all still bound together by gravity. So astronomers postulated that there must be something out there that has gravity but doesn't emit light. And that's why we know there's dark matter out there. And over the years, we've gotten better and better at being able to figure out how to detect dark matter, pardon me. Even though it doesn't emit light, it has effects. It has gravitational effects. So we don't know what dark matter is, but we know it exists. Well, it's the same sort of thing with dark energy, except it's even more mysterious. We know that the universe is expanding. As you look at galaxies that are farther and farther away, they're moving away faster and faster. And this is sort of characteristic of an explosion. If you let a bomb blow up, you count to 5 and take a picture, the stuff that's moving the fastest will be farthest away from the center of the explosion. The stuff that's moving slowest won't have gotten as far. So basically, if you were somewhere in an explosion, you would see that more distant things are farther away. And we see the same thing in the universe, so that we know that it has the characteristics of an explosion. And that 13.7 billion years ago, everything was sort of compacted into a single spot. I'm hand-waving a little bit here. This isn't the most accurate way to describe it, but this is good enough. There was basically an explosion, not of matter, but of space itself. Space and time came into existence at that moment and expanded outward. And it's sort of dragging the galaxies and everything with it. So when we look at a galaxy that's really far away, it's moving away faster. Well, in 1998, 2 different teams of astronomers independently discovered that the universe appeared to be accelerating. It wasn't just getting fat. It wasn't just expanding. Or you might expect the expansion to be slowing over time because the gravity of all the objects in it's dragging on it, making it expand more slowly. But in fact, it was expanding faster. It's expanding faster every hour of every day of every century since it formed, or at least for quite some time. And that's exactly the opposite of what you expect. And so what they said was, well, gosh, there must be something else, some sort of energy that is expanding the universe faster all the time. And it's sort of like you're pumping fire into a hot air balloon that makes it expand, and it expands faster and faster. As opposed to dark matter, we've been able to observe dark matter for some time and eliminate a lot of things it could be. We know it's not stars, we know it's not black holes, we know it's not planets, it's not gas. It must be some exotic form of matter that at least we have an idea of what it might be. With dark energy, we have a gazillion ideas of what it might be, but no real idea of what it is. We don't know enough about it, I think, to eliminate enough possibilities to have a solid grasp of what it is, as opposed to dark matter, or even dark matter, not that solid a grasp. So my point is, dark matter is very mysterious, but at least we've been able to eliminate a few things. With dark energy, we've been able to eliminate some hypotheses of what it is, but we still have a huge number of things it might be. We know that dark matter is real. We know that dark energy is real. We have a little bit of an idea of what dark matter is. We have almost no clue what dark energy is. So that, to me, is the most mysterious thing in the universe. And wow, I'm like really giving long answers here. I really need to tighten this up a little bit. The thing is, though, dark matter and dark energy, it takes a little bit of explanation to give you the background idea of what's going on here. All right, I'm refreshing the screen to see some new questions. I see I have 117 plus ones. Thank you, folks. That's excellent. Scrolling down. P. Stemish asks, are you going to do more bad astronomy posts dealing with the likes of Richard Hoagland and astrogaps and movies like you did in the original site? Ah, you're from San Francisco, my old stomping ground. I lived in Sonoma County for 5 or 6 years. Yes and no. Specifically, Richard Hoagland is a guy who couldn't find reality with a pickaxe and a compass and Google Maps, basically. Talks about the face on Mars and interdimensional, transdimensional people from whatever, and it basically just spouts nonsense 99.9999% of the time. I don't waste my time on people like him anymore. You know what? He's going to spout his nonsense. I've already written about him on my old Bad Astronomy website. Look up my name, Phil Plait, plus Richard Hoagland, and you'll find everything I said about him. He hasn't said anything new since then, so the heck with it. There are flavors of pseudoscience, of anti-science, that I've already thoroughly debunked, and there's no need to go over them again. There are people who say comets are hot. Comets are cold. They're made of gases, things we think of gases like ammonia and methane and carbon dioxide and carbon monoxide, that are frozen into ice, and so we know comets are cold. And there are people out there saying, no, they're hot and blah, blah, blah. And it's like, no, and I've written about that, done. There are also, and this comes up a lot, there are these ideas that come out that are just not worth worrying about. People who say there are giant crystal structures on the moon. People who are saying there are flying saucers in pictures of the sun. There's a new one that just came out. This Russian scientist is saying that pictures from a Russian probe, a Soviet probe, I guess at that point, that had landed on the surface of Venus is showing evidence of life. And it's like, no, this is just rocks that look like other things. And he's saying they're moving around, and it's like, well, okay, great. Let's say they're moving around. Let's say he's right. I haven't seen his paper that he's published. It's firewalled, and I can't see it. I'm going to hopefully get to take a look at it this week because I'm just curious. But sure, okay, I'll grant him that some of these things have moved. But Venus has an atmosphere, and it's very, very thick, and it moves around. So it could easily push stuff around. But that doesn't mean it's life. You know, if I see sand blowing in the wind on the beach, that doesn't mean the sand is alive. And just because something looks like something else doesn't mean it's alive. You know, there are rocks that look like faces. I just posted, well, it's a bad example. I posted a cancer cell that had a smiley face in it. That cell is alive, but you know, if you look at a cloud, you can see faces all the time. I saw a cloud yesterday, this is true, that looked like a dragon riding a skateboard. That's called pareidolia. That's seeing shapes that you recognize in sort of random or at least shapes that don't really have anything to do with that. Faces in clouds, you know, outlines of trees, rocks, they look like faces, they look like animals, whatever. It's not real. So, you know, I could debunk this guy, I could write a long thing about it, but honestly, in a week, nobody's going to remember this. On the other hand, when it comes to 2012 garbage, that's really scaring people. When it comes to the Mayan prophecy and all that, that's worth tackling because it's scaring people, and people are making decisions of, you know, life decisions based on nonsense. And I will be writing about that very soon. I've got a lot on my plate right now, but I will be tackling that pretty soon. So, you know, I will be writing more stuff like that. But it's actually hard to know what's going to be big and what isn't. Sometimes, you know, invading spaceships, you know, pictures were taken by observatories, and I think, ugh. And the next thing I know, that hits the web like a bomb, and everybody's talking about it, so I have to sit there and write about it. It's a pain in the butt. Let's see, going down. Phil, in light of Emily Lakdawala's new cool props of science, do you plan to upgrade yours? Emily Lakdawala is actually creating, she has a word for it, I can't remember, but they're these plastic sort of grids that you can weave yarn in and out of, and she's been making models of some of the planetary probes. They're really cool. She writes for the Planetary Society's blog, so if you go to planetary.org/blog, you'll get Emily's blog. I highly recommend reading her stuff. I create props as I need them. So, you know, I was using my Milky Way thing. I've got some squishy balls I use, the Earth, the Moon, or whatever. I've got a few other things, and I make them as I need them. So, yeah, I'll be making more as I figure I need more. I need a little rocket ship. I need to make one of Saturn. I'll probably make one like this. The thing is, this is to scale. If the galaxy's 100,000 light years wide and a couple of thousand light years in thickness, this is about right. With Saturn, though, the rings are so thin, I'd have to actually... Even a piece of paper to scale is thicker than Saturn's rings. So that's hard to do. I'll figure that out at some point. I don't know what I'll do about that. Let's see, let me check Twitter. Oh my gosh, there's lots of stuff going on Twitter. We can hear you. Thank you. Some repeats of the same questions. Let's see, scrolling up. Some global warming stuff. Pardon me again, this is live, so I'm scrolling through the pictures. Okay, there are no... Oh, here's a question from Loveland, Colorado, right up the street. I was just in Loveland. The Mythbusters were there on tour. That was fun. Greetings from Loveland, Colorado, says Gravy or Gravy on Twitter. Question, Carl Sagan, great human being or the greatest human being ever? As a human being, you know, I didn't know Carl Sagan. I've read his biography, and he seemed like a pretty cool guy, flawed like everybody, right? He had his problems, but I think his heart was in the right place, and he was a good scientist, despite what a lot of people complain about his science, this and that. His science was actually quite good. He was a planetary astronomer. He did a lot of great stuff. He was probably he may not have been the first great public outreach astronomer. There were many astronomers who did it before him, but he was the first sort of to break into television on the Carson show, on the Tonight Show, Johnny Carson. And of course, Cosmos was fantastic. and has been seen by hundreds of millions of people, and is being remade with Seth MacFarlane, Family Guy. Seth MacFarlane is actually a huge science aficionado and a brilliant guy, and so he's producing this with Neil Tyson, who is going to do a fantastic job. Neil's a good guy. So that's great. I'm glad even more people will probably see that. So Carl Sagan did so much for public outreach with astronomy, and I think in that venue, he was unparalleled. I'd have a hard time coming up with somebody who has as big of a footprint as Sagan did. So I love his stuff, and you can pick up any of his books. Broca's Brain, Ancestors. I have them all actually over there. I'd have to look at them. But Cosmos, Pale Blue Dot, Billions and Billions, and of course, oh my gosh, what am I thinking? Demon Haunted World. Demon Haunted World is awesome. It's as close to a skeptic Bible as you can get, and it was incredible. So let's see. Jenny Liebman asks, hi Phil, Astro Jenny here. Hi, yeah, I'm tweeting all the time. Here in Yorkshire, UK, possible that Curiosity drill bit's integrity has been compromised. Now, Curiosity is the Mars Science Laboratory. It's on its way to Mars right now. It's the size of a golf cart, and it's much larger, much more sophisticated, much more advanced than the rovers we put on Mars. It just launched a little while ago. It's going to land, I want to say April, but it's going to land this year, and a huge amount of work on Mars. It's going to be great. She's saying the drill bit has been compromised. I've not heard this. Is that going to cast doubt on any discoveries of possible signs of life the rover may find? I don't know. I know that drilling into the surface of Mars is critical for doing chemistry experiments to see if there are signs of life. One thing life does is it changes the chemistry of the environment around it, because life ingests things and then expels things, whether it's yeast eating, absorbing sugar and expelling carbon dioxide, or us, we breathe oxygen and expel carbon dioxide. We eat carbohydrates and all these other things and expel waste material. Try not to be indelicate there. So you can look for these changes in chemistry. For example, the best thing you can do is try to find a chemical that is very delicate, that's very fragile, that's out of equilibrium balance. So in other words, if you have just a planet and it's got a little bit of volcanism and a little bit of water and a little bit of that, you might expect to see some methane in the atmosphere. The thing is, methane is a very reactive molecule. So if there's a little bit of oxygen in the air and a spark, boom, it catches on fire. If you find that there's a lot more methane than you'd expect from volcanism and natural chemical reactions, you might suspect life. Same thing with oxygen. Oxygen molecules, two oxygen atoms bonded together to make an O2 molecule, hugely reactive. And so if you go to a planet, or you look at a planet through a telescope, you take a spectrum and you see the signature of O2, that's really interesting. You might expect then, or certainly if you see a lot of it. If you look at the Earth from a distance, you would see a lot of O2 in the atmosphere, way more than you would expect from just geologic processes. And so if you were looking for life on other planets, that would be a great way to do it. It's a signature of biology. And so the rovers are going to do this. Curiosity is going to do this on Mars as well. If the drill bit is compromised, I don't know. I'm not that familiar with it. This is a good question for Emily Lakdawala. So maybe somebody can ask that on Thursday's roundup, because I'm sure she'll be there. A lot of the older rovers could scoop a little bit or could scrape rocks and look for things that way. So I'm not exactly sure how this will compromise the mission, but that would be really awful. However, there's still plenty of time, I would think, to diagnose this. I'll have to look this up and see what I can find out about the drill bit having a problem. But it's on its way to Mars. It'll land in a few months, so hopefully there's time to figure this out and fix it. But I really can't say anything more than that. Let's see. From Romania, Vasily Bodisat. Bodisat. That's a cool name. I love Slavic names. I have Slavic ancestors, and I love it. The fewer vowels, the better. It's awesome. Asking, we should colonize first the Moon or Mars? Which side are you on? Oh, that's a good one. they're different, right? Getting to the moon in some ways is easier, in some ways harder. Getting to the moon is easier because it's closer, and it's only a 3-day trip, 4 or 5 days. It depends on how you get there. You can take months to get there if you do some crazy orbit that doesn't use much fuel, or like Apollo, or like some of the probes we've sent there. You sent, I can use my moon model and my Earth model, right? They're only 400,000 kilometers apart, about 250,000 miles. So at rocket speeds, it takes about 3 days to get from point A to point B here. You have to use rockets to land. The moon doesn't have any air. So you have to bring enough fuel with you to land, and you have to bring enough fuel to come back. Or you can try to mine the surface of the moon to make fuel to come back. And there's some people who are thinking about how to do that. That would be nice because then you don't have to bring all that fuel with you. And you can use that to bring, instead of bringing fuel, you can bring water or air or food or things you need to build materials. So getting to the moon's a lot easier. You only need to bring 3 days worth of air to get there, plus however long you're going to stay. To get to Mars, it takes 6 months. So getting to Mars takes a lot longer, and you have to bring all that food and air and water and everything with you, and it adds up to a huge amount. You can't just send a little lunar lander to Mars. You have to send a huge, huge, huge thing that has a tremendous amount of supplies on it. Also, to get to Mars taking 6 months versus the moon taking 3 days, if the sun decides to hiccup and blow out a solar flare, or what's called a coronal mass ejection, this wave of subatomic particles, that amount of radiation can hurt your electronics, and it can hurt your astronauts. So the quicker you can get to your target and protect yourself, the better. So again, getting to the moon's a lot easier. The odds, in the course of a year, the odds of the sun blasting out one of these particle events over 3 days is much lower than over 6 months. It's almost a certainty in 6 months something's going to happen. So the radiation issues. On the other hand, once you're on Mars, it has a thin atmosphere of carbon dioxide. That can be useful. The soil on Mars, it's not soil, it's regolith, it's ground up rock. Soil is actually processed by bacteria, it's a technical term. But once you get to Mars, there are chemicals in the surface there that you can also process to make oxygen, water, fuel. There's a lot more water on Mars than on the moon. We're finding there's plenty of water in the ice caps, frozen as ice. And we're finding that even in mid-latitudes on Mars, if you dig down a little bit, there's lots of ice there, and that can be used as water. There's water frozen on the moon, but it's spread out a lot more thinly, so it's a lot harder to get to. So in that case, Mars is a better place to live for the long term. So again, back and forth, back and forth. I think logically it makes more sense to go to the moon first. That's the bottom line. It's closer, it's faster. If we need to bring our own stuff, we can just send another rocket and get it there, as opposed to having to wait months to do that to get to Mars. They can protect themselves by radiation just as easily as on Mars by burying themselves in the surface. And there is water on the moon trapped in the poles in craters that are deep where the sunlight never reaches. So you could maybe mine that, or but even if you can't, we can figure out other ways of getting it to the moon. So in my opinion, in the long run, over the next century, we should do both. But I think it makes more sense to go to the moon first because it's cheaper, faster, easier, and it's a learning experience. If there are any problems, we might be able to fix it better at the moon. And the things we learn there, hopefully, will translate to being able to go to Mars, which in almost every way is much, much, much harder. There you go. Again, I'm just... David Wheeler's pointing out high probability of aurora tonight. This is true. The sun had it wasn't a big flare yesterday morning, I think it was, as I'm doing this live chat, but it was directed right towards the Earth. So there are subatomic particles coming to the Earth. You don't have to worry about getting hurt. Our atmosphere protects us down here. Our magnetic field protects us from these as well. I haven't heard any alerts that astronauts in the space station need to be taking any precautions, so I think they're going to be okay, but I may have missed that. But the good news is that when these things hit our magnetic field, that can interact with the magnetism of the Earth. These particles are focused to the North and South Pole, where they slam into our atmosphere and glow. They ionize, they strip an electron from the atoms and molecules in the upper atmosphere, and when those electrons recombine, they glow. This is exactly how a neon sign works. So the gas in a neon sign you ionize it, you strip the electrons off with electricity, and when those electrons recombine, they glow at specific colors. Oxygen glows green, nitrogen glows red, different colors glow at different elements and molecules glow at different colors. And that's why we have the aurora borealis in the northern hemisphere and the aurora australis in the southern hemisphere. And so if you live in northern latitudes, you might get a chance to see an aurora tonight. And I've already heard a couple of people on Twitter saying they're seeing them way far east of here where it's already nighttime. I live in Boulder, Colorado. It's pretty rare where we are to see the aurora, but if you live up in Canada, like in Alberta or places like that, it's a good chance. Or Alaska, or on the other side of the world, if you live in Scandinavian countries, that area, go out. And if you go to spaceweather.com, they will typically post alerts. And there is the National Space Weather Center. National Space Weather Center. It's here in Boulder. If you look up space weather in Boulder, you'll get to that site, and they have all kinds of maps that'll show you where you live if you can see an aurora or not. But if it's clear where you are, oops, sorry, whacked the microphone there. Hope I didn't deafen anybody. If you live anywhere and it's clear tonight, I would suggest going out and taking a look. If you're in the northern hemisphere, look north, and the southern hemisphere, look south, because you might see something. And of course, it's cloudy here. Figures. Very rarely cloudy in Boulder, but it's usually when something interesting is happening. Here's a question I get a lot from Michael Vidalans in Sweden, and I'm sorry if I mispronounce your names. I'm a big ham-fisted American. Some tips for purchasing a telescope, please, for seeing galaxies and close-ups of our planets. Get this question all the time. My immediate answer for this, when somebody says, what kind of telescope should I buy, is I say, this is like asking me, out of the blue, what kind of car should I buy? You know, I don't know. Do you live on a mountaintop? Do you live near the ocean? Do you want to haul logs for your fireplace? Are you just driving the kids to school? Do you have a lot of money? Do you not have very much money? There's a million kind of cars to get. It's the same thing with telescopes. If you're looking for something inexpensive, that limits you. If you have $20,000 to spend, you can buy anything you want, just about. Do you want to look at the moon and planets? Do you want to look at faint, fuzzy things like nebulae and galaxies? It's a tough question to answer. So, in fact, if you search on Google, and you're watching me on Google, so you can actually search this. Let me find. Let's see. I'll type in my name, Phil Plait. I'll do this live here. Telescope buying, and see if that takes you. I'm trying to find the right search words. Perfect. If you type in my name, Phil Plait, telescope buying, it'll take you to my bite-sized astronomy page, which is a series of web pages I wrote years ago that has a list of just sort of a general description of the different kind of telescopes and links where you can find more information. And I'm looking down because I actually have a more, a more updated link. If you search, hang on a second, again, this is live, so give me a moment. Just trying to find, I wrote a blog post about this right before the holidays in December, and, oh dear, I'm not finding it. Oh, that's upsetting. Well, whatever. I've written blog posts about this. You can go to universetoday.com and do a search there. There are a lot of websites out there that will give you advice for what you want to do. And there are a lot of really good, inexpensive starter telescopes out there. The one piece of advice I tell people that I think is the best piece of advice you can get from anybody is find a local astronomy club. They are everywhere, all over the world. And if you live in any reasonably populated place, there's probably one within an hour's drive. And they will hold star parties, because that's what amateur astronomers do. And they'll announce it on their website. And so you can go there and say, oh, look, there's a star party coming up where they will have a few different telescopes there. You can go and see the different kinds of telescopes, from very inexpensive ones that are easy to use in many cases to the higher end ones, which are more difficult and take a little bit longer to learn. And then you can see what it's like through these different telescopes. And you have to be careful. It's like looking at a Ferrari and then realizing you don't have 80 grand to spend on a car. You don't want to see too nice of a telescope, because then you'll think, oh, I don't want to get this cheap one. But in fact, an inexpensive telescope for a couple $100 can do really great stuff. Galileo's telescope was a piece of junk, but he discovered Jupiter's moons. He saw Saturn's rings, even though he didn't really know what he was looking at. craters on the moon, and other things as well. So you don't need a huge telescope to do a good job. And I'll also note that Fraser Cain from Universe Today on Google+, he and I and Pamela Gay will be doing live telescope viewings where we'll have star parties online. Astronomers with webcams they can put on their telescopes. We've already done this many times. It's a huge amount of fun. We've looked at the moon, Jupiter, Mars, Saturn, Orion Nebula. It's fantastic, and that'll do a good job showing you what kind of telescopes they are too, because we talk about them. People in Twitter are actually posting some links. So Gravy again posted a link to my scope fac on buying a scope. And somebody else posted, let's see, David Wheeler, PhD, Dr. David Wheeler, posted a link to a place you can get Aurora information, so that's cool. Oh my gosh, there are like a billion questions now. I can't even possibly keep up with this. Oh, here's a good one, Russell Bateman. Oh, hi, Russell. Yeah, tweets, comments a lot on Twitter, I believe. When comet Lulin made its pass, this was a comet from last year, I observed its vibrant green color using my telescope. I read this green color comes from cyanogen gas and diatomic carbon, which both glow green in sunlight. If Earth were to pass through the tail of a comet like Lulin, full of cyanogen gas, would our atmosphere protect us from this poisonous gas or provide no protection at all? Great question. This is actually two different questions. First of all, to answer the scarier thing, yes, there is cyanogen, which is a poisonous gas in comets and in their tails. But you know what? Hang on a sec. I'm going to do this right. One of the things I want to do while I'm doing these chats is if I get a question like that and I can answer it quickly and easily with sort of definitive answers, then what I can do is it'll be in the long, when I'm done with all this, this will go, the whole thing will go up on YouTube, the whole hour and whatever minutes. But I can edit out short pieces of it and put those up as well, so they answer some questions. Hang on, that is not the right place. I actually know the answers to this, and I have to be careful because it turns out there's a widespread misconception about why comets are green, and I need to find the letter I got from somebody telling me about this, and it turns out here it is. Okay, got it. So what I'm going to do is I'll probably only do it this one time because we're already 45 minutes into this. But in the future, as I'm going to try to do these pretty often, maybe even every Sunday. I'll stop, reset, and reintroduce everything fresh from the start. So I will do that right now. Hey, Phil Play from badastronomy.com here. I'm doing Q&BA, which is my question and answer, let me try that again. Take two. Hey, Phil Play from badastronomy.com. Welcome to Q&BA, where I answer your questions about science. I'm in the middle of a live session right now with Google+, and I got a great question, which is perfect for a short, nice answer, and that is from Russell Bateman, who asks, when comet Lulin, a comet which passed near the Earth last year and was not that close, but it was a good telescopic object. When comet Lulin made its pass, I observed its vibrant green color using my telescope. I read that this green color comes from cyanogen gas and diatomic carbon, which both glow green in sunlight. If Earth were to pass through the tail of a comet like this, full of cyanogen gas, would our atmosphere protect us from this poisonous gas, or would it provide no protection at all? Now, this is, interestingly, two questions. There's the main question. Would we be poisoned from cyanogen gas, which is a deadly toxic gas? And the answer is no. Because even though comets look bright and beautiful through a telescope, or sometimes even when you look up in the sky, there are times when they're bright enough to be seen with the naked eye, the tail is actually a pretty high-grade vacuum. You're just seeing a lot of it, and you're seeing through a long amount of it, thousands and thousands of miles of it. But if you were to be in it, you would suffocate. It's basically a vacuum. There's just very few particles in there. And the amount of cyanogen in there just isn't enough to hurt you. You'd have to collect probably the entire tail and throw somebody in a room full of that to have any effect. I'd have to do the math for that. But basically the bottom line is the Earth can pass right through the tail of a comet, and there's basically no effect at all. We did this in 1910. We passed through the tail of Comet Halley, which a lot of people call Halley's Comet or Halley's Comet. It's actually Halley, pronounced Halley. He was English. But we passed right through it, and there was no effect at all. People were panicking about it. There were people selling comet pills, snake oil basically, to protect people. It was nonsense. It's nice to know that we've gotten all past that, right? Yeah, not really. There's still people out there selling all kinds of ridiculous medications for things that don't exist. The medications don't work anyway. But there's no effect. So that's not a problem. And in fact, we pass through the tails of comets all the time. Every time you read about a meteor shower, we're passing through the tail of a comet. As comets go around the sun, they slowly disintegrate, and little pieces of ice and rock and everything follow along in the cometary orbit. And as the Earth plows through that, we get meteor showers. And except for just one or two out of the dozens of showers, these all come from comets. A couple of them come from asteroids, but most of them are from comets. Now, part two of this question is interesting. Cyanogen is this deadly gas. Diatomic carbon is just two carbon atoms bound together, and that emits green light. And if you go almost anywhere on the web, including a couple of places where I've written about this, you will see that those molecules emit green light. But it turns out cyanogen just isn't really a big emitter in comets. When you actually look at the amount of cyanogen compared to diatomic carbon, the amount of light from diatomic carbon is much, much, much larger. And I actually got a letter from a guy named Frank Suits, who's a PhD, a long time ago, and I've been meaning to write about this, because I've mentioned a couple of times that comets emit green because of this. And he even told me, people post that green is due to cyanogen. However, CN, the cyanogen molecule, actually emits mostly in the ultraviolet. It does emit some in the green, but it's not very much. C2 is the primary emitter of green light in a comet. I didn't know this. And I've said this, and you can buy filters that are labeled cyanogen filters for comets from manufacturers, and it turns out that's not right. That's not where the green light from comets is coming from. And I've actually seen comets through my own telescope and through binoculars that are glowing a faint green. They tend to be just gray. They're not very bright. When you take deep exposures, you might see a blue tail and a red tail. Comets have two different tails sometimes. But sometimes they really do emit in green. You can find this all over the web. If you look for green comets, you'll find tons of pictures. And it turns out that really is from diatomic carbon. He was absolutely right. And I need to write about this because I've made that mistake as well. And it just goes to show you that when you look stuff up, even from people you might consider experts, it's not right. When you look at the spectrum of a comet, it's the carbon that is where that's coming from. So I'd like to thank Russell Bateman for sending that question because it clears up sort of a misconception about how comets can affect the Earth. It turns out they can't unless they hit us directly, really. And a misconception on the more technical side. So I like that. We get a twofer out of that. So thanks. Okay, so I hope that went well. Let's see. I'll refresh the Google Plus page. I'll go back to the top, page up. I have 162 plus ones. Thank you. If you're in here, if you're listening to me right now, you're in the Google Plus post where the YouTube player is embedded. And if you're actually signed up for Google Plus, on the bottom left there's a Google Plus One button. Please click that, and that lets me know how many people are in here. 162 is pretty nice. That's a nice amount. I'm getting so many questions I cannot possibly get to them. I'm only going to take a couple more. I started a little late. Let's see. Mikhail Vidalans tells me I pronounced his name correctly. Probably the first time, not that time there. Thanks. Cool. I met somebody whose last name was Kurzestafovitz. And it was written down, and I basically said, "Oh, you're Mr. Kurzestafovitz." And he looked at me and said, "How did you know how to pronounce that?" Like I said, the fewer vowels, the better. That was fun. This is a great question from it's from Sweden, and it's spelled Jonas Majors, so I'm sure it's actually Jonas Majors or something like that. I really don't know much Swedish. I just know that 20 is 20 in Swedish. That's the only word I know. It says, "Hi, Phil. Do you have any good directions for star maps?" Now, what I think you mean is, do I have any good star maps I recommend? And it turns out, yeah, a couple. Stellarium, which is Stellarium, is a free bit of software. It is from SourceForge, which is an open source software repository where you can download the actual code and add to it, do things you want to it, and if it really works, you can send it out to the community. It'll get approved and added to the actual code. Stellarium is great. you can tell it where you are and what time it is, and it'll tell you what's up in the sky. And it has a lot of different layers to it, different things that people have added over the years. So that's a really good one. I use an inexpensive one that I bought in December because they were donating money to a great organization called Astronomers Without Borders. I bought one called Sky Safari. I have it on my iPad. Here it is here. I don't know how well you can see that, but it's pretty good. And you put in your location, and again, it has really nice maps here, and it shows you where the planets are, where the stars are. You can advance it by hours, days, minutes. It's totally interactive. That's a good one too. That's Sky Safari. They have a professional version and a cheaper version. It's like $3 or $4, something like that. And the other thing I would recommend is Heavens Above, heavens-above.com. If you go there, you put in your latitude and longitude, which you can get off Google Maps or whatever, and it'll tell you what you can see in the sky, where the planets are, how far away they are. There are different lanes for that. My favorite thing is it tells you all the satellites that are up right now, and it's very accurate. So if it says the space station is going to be passing from southwest to northwest, it's going to be 30 degrees above the horizon at 6:02 tonight and be at magnitude 2.4, you can pretty much count on it and go out there and see it. So it's a really great way of seeing what satellites are up. I use it all the time. I check it at least every few days so that I can go out and see cool satellites. So that's Stellarium, if you look that up, Sky Safari, which I like, and Heavens Above, heavens-above.com. There are 100 more. So, just look them up online. You'll find tons of them. They're a lot of fun. If you get confused by how to use them, because it's a little weird using a map of the sky, you're used to seeing maps where you're looking down on roads and that sort of thing. It's a little bit weird. Again, find an amateur astronomy club near you, a society you can go to, and they'll be happy. Amateur astronomers are the most outgoing group of, if you wanted to overgeneralize about a group of people, they are so outgoing, so willing to show the public stuff that they'll be happy to help you with that sort of thing. And if it turns out they're not, I will take no beef for that. Let's see. Sorry, scrolling up. And Daniel Evans said stellarium.org. There you go. So yeah, if you're in my my post stream with the embedded YouTube video, and you've clicked +1 or not, there are lots of comments here. Go ahead and leave a comment. Say, I like the star map. Great, do that. Help me, help you, help everybody else. Perfect. Let's see. Well, here's a good one from Jeremy Rogy. Oh man, R-O-G-G-Y. I don't know how to pronounce that. I took 2 years of French. Rogi? It's an interesting name. He asks, what's your opinion of Zubrin's plans to get to Mars? Is it really feasible to get to Mars as he claims? Robert Zubrin is an engineer, and he's written several books about this. The biggest one is called The Case for Mars, which I read many years ago when it came out. He was president of the Mars Society. I actually don't know what his status is with that anymore. I haven't. It's hard for me to keep up with all these different groups and everything. But the Mars Society is a group that promotes exploration of Mars and getting humans to Mars. And he had this plan where you would send an advanced ship to Mars. It would land on the surface. It would have basically a chemical factory on board. It would scoop up. It would draw in air. It would draw in the surface materials, the regolith, as it's called. And it would create oxygen, it would create water, and it would also create the chemicals you need to make fuel, hydrogen peroxide, for example. Not like you buy at the store to put on a cut to sterilize it. Pure hydrogen peroxide is extremely volatile, and it makes a great rocket fuel. The stuff you buy at the store is like 3%. But if you buy it at 100%, it makes good rocket fuel. So that's one thing you can create there out of the Martian surface. So you launch this rocket, you put it on Mars, you let it churn away, a little factory churning away, and then you send people there. You send supplies of food and everything. Then you send the people there, and so they get there, and everything's prefab. It's already made for them there. I think that's a fantastic idea. The problem with it is it's not tested, and getting to Mars is hard and expensive, and so even if if you're doing it that way, you have a lot of single points of failure, where if the food thing doesn't work, if the air thing doesn't work, if the water thing doesn't work, if the fuel thing doesn't work, you don't want to find that out when your astronauts are 2 weeks from landing on Mars after a 6-month trip. So it's a cool idea, and I think its day will come. I don't think rocket technology is reliable enough yet, but give it time, right? We have SpaceX. We have some other companies, Blue Origins and a few others, that are building rockets. And SpaceX is doing a pretty decent job. They're going slowly, but they're making positive steps towards creating rockets that can go to Mars. And it may only be 20 years before we're seeing something like what Zubrin wants, because by then we'll have big rockets that can do this. And if one of them doesn't work, shoot up another one, because they don't cost $1 billion each. They only cost $100 million each, and it turns out that's a lot cheaper. I don't mean these numbers to be accurate. I'm just giving you sort of a scale here. And it's entirely possible that'll happen. Maybe not in 20 years. Maybe it'll be 30. Maybe it'll be 10. I don't know. But we'll see how all this works. Oh, somebody pointed out I forgot to post a link on my blog. Oh, drat. And I'm almost done, so too late now. I'll try to remember to do that next time. That's what I get for doing this live. Okay, let me refresh the screen. We'll go down to the bottom. Let's see. And I'm looking on Twitter right now. No, there are no questions on Twitter. Ooh, we almost have 200 plus ones. Pluses one. Pluses one. Plus ones. Pluses ones. Pluses ones. We'll go with that. People liking Heavens Above. Stellarium. Reading. Jonathan Christian asks, assuming the Higgs boson is isolated, what's next? What are the practical implications? Wow, I don't know. That's a good question. Most particle physicists expect that the Higgs boson we will see unambiguous detection of it very soon. The Large Hadron Collider is looking for this in Geneva, and basically the Higgs boson. It's complicated. I'm way oversimplifying it, but it's basically responsible for mass. Why do we have mass? Why does this thing have mass to it and some things don't? A photon doesn't have mass. There are a lot of particles that don't, and a lot of particles that do. The proton, the electron, the neutron. These have mass and some don't. Basically, the Higgs is responsible for that. But according to theory, this model of how particles works shows that mass should arise because of another particle, and this was originally determined by a physicist named Higgs, and that's why it's called the Higgs particle. It's never been seen. We kind of know how much energy this particle should have. Every particle has sort of an energy as an attribute. The proton has a lot more energy than an electron, and so on. So what you do is you smash particles together, and then you can basically, there's shrapnel that blows out, and if the Higgs is in there, there should be a signature at that energy range that shows that there was a particle emitting, that had this much energy. And it's kind of like firing a bullet at an unknown target. Shrapnel's blown off, and then you can see by the chunks of the shrapnel what the thing was made of. And the recent results were, from the Large Hadron Collider that they announced a couple of months ago, that to an interesting amount of statistical certainty, they saw something at a certain energy range where they expected to find the Higgs. The problem is it wasn't 99.999% sure. It was not quite enough for you to go, yeah, that's it. It's like having a deck of cards, flipping over the top cards and saying it's the ace of spades. It's like, oh, what are the odds? The odds are 1 in 52. It could have been any card. And so you have to do that many, many, many times. And if you get the ace of spades over and over and over and over again, then you know something's up. But if every time you flip the card, it's just a random card every time, it's just a random process. It's the same thing with the Higgs. We have to keep observing it over and over and over again and make sure that there really is something there, and it's not just random chance. Most particle physicists are now basically saying, yeah, the Higgs exists, we're going to find it and everything's great. That may not happen. And they're all saying the same thing. They're saying we expect that. We kind of hope that doesn't happen, because if that doesn't happen, that means there's more interesting things going on. The Higgs particle is such a well I don't want to say understood, but it's what they expect so strongly that if they find it, they're going to go, oh, yeah, we found it. All right, great. We expected that. But if they don't find it, then there's something else going on. And that's cool. That means they have to go back and try to figure that out. And that means more fun, more mystery, more problems and puzzles to solve. So they love that. But if they find it, what's next? I don't know. That's a good question. Finding out how it behaves, finding out, narrowing it down, getting the energy distribution of this particle tighter and tighter and tighter so we know just how much energy it has, to try to figure out how it interacts with other particles, because maybe it exists, but maybe it interacts with other particles in a way we didn't expect. And that would just be with the Higgs. That's not all the Large Hadron Collider is doing. It's looking for other things. There's one detector in there that's looking for dark matter. We know that dark matter is, like I said earlier in the chat, it's not made of gas, it's not made of planets, it's not made of dead stars. It's some other type of particle, some weird thing out there that we don't really understand. Axions or some weird subatomic particle like that. And they're looking for the signature of that. And that's a pretty cool project. Once we find out what kind of particles dark matter is made of, who knows what we're going to learn from that. And the practical implications? Who knows? Of what practical use is a baby? Right? This I can't remember who said that. I read it in the Robert Heinlein story a long time ago. But honestly, don't worry about the practical applications. Those will come eventually. James Clerk Maxwell, a Scottish mathematician, sat in his room and worked out 4 basic equations of how electromagnetic energy works. And electromagnetic energy is light and magnetism together. And they didn't know in the 1800s how this stuff worked. He wrote down 4 basic equations and said, this is how this stuff works. And basically spawned everything we do today. The electronics industry, television, radio, the internet. Once you understand how electromagnetism works, you can then use it. So he didn't have practical applications in mind when he did this, and yet it has spawned industries which are worth trillions of dollars. Who knows when we find the Higgs? Maybe in 100 years or 1,000 years or whatever, that'll help us control gravity. Maybe we'll be able to make wormholes with it. I'm making this up. I have no idea. Maybe it's nothing. But what we've learned over time, and I had to tell my daughter about this because she's in high school learning math, that it almost doesn't matter how obscure an equation is. When there's we used to make the joke about the Russian mathematicians sitting in their basement solving integral equations, complicated equations, and you think, oh, this has no practical application, it's just theoretical math. That never happens. These equations always have some sort of practical application. It's as if the language of math is woven into the fabric of the universe. The universe itself behaves according to these mathematical rules. So when you uncover some mathematical rule, somewhere out there, it has a footprint on what's really happening in the physical universe. So I try to never say, that has no practical application. It very well might. And who knows? Anybody's guess is as good as mine. All right, let me refresh the chat room. I guess it's 2:15. You know what? I'm going to take one more. Oh, look at that. Exactly 200 plus ones. Thank you, folks. Let me take a sip of water here. I'm dying. You know what? This is a perfect question. This is perfect. Great way to end this up. From Ali Marie in Chicago, Illinois. Lived in Chicago for a year. Harold's Fried Chicken, best in the world. And I've had every piece of fried chicken in the world, so I can say that. You know what? I'm going to do this one as a Q&BA short as well. I'm just going to make this up as I go along, but we'll see how this works. So let me sit back here and reset. Hey, Phil Play from badastronomy.com here, doing a live Q&BA chat session on Google+. And I got a great question. It is from Ali Marie from Chicago, Illinois, who asks, what is the best way, in your opinion, to draw kids into science and skepticism from a young age? It's a really good question. I like this question a lot. It's more philosophical, but it has a practical application. Kids are natural scientists, and they love sort of the basic stuff about science. They want to name everything. They want to catalog everything. They want to categorize everything. This is a rock. This is an animal. That's a tree. Right? And when they're very young, when you do that sort of thing, that helps you understand things better. You put things into general groups. That's a very human thing to do, to help you narrow down the possibilities of it so that you can understand it better. This has its drawbacks, because then it becomes very easy to overgeneralize, and that might have bad implications like, racism or sexism. On the other hand, it does help you get a grip on things. Now, I could show you a picture of a panda and a chameleon and say, what do these two things have in common? And you can say, well, they have 4 legs. They're quadrupeds. And that's good, and that helps you maybe understand how they move around and how they do things. On the other hand, the panda is a very different type of animal than a chameleon. So, one's warm-blooded, one's cold-blooded. One is big, one is small, scales, one has fur, right? And these similarities and differences tell you a lot about them, and that helps. And kids do that very naturally. So I would say encourage that with kids, but make sure that they're not over-specifying things and say, oh, those do have 4 legs, but look at the color of this one versus that. Show the differences as well as the similarities. And that will help them broaden their mind and not get too narrow about this. On the flip side of that, kids tend to believe authority. That's an evolutionary trait. Kids want to believe what their parents tell them, so parents can say things that might be incorrect, or there might be a belief system that may not map to reality terribly well. And so I would caution you about that as well. But if you encourage the kids to ask questions, that is probably, if I had to say, what is the one thing we can do to encourage kids to think about things, to be more scientific, more skeptical, I would say encourage them to ask questions. Never say that's a dumb question. If you don't know, say, I don't know. And then say, or even better, say, I don't know, let's find out. I wrote this in a post recently that one of the most powerful words in science is yet. I don't know yet. Let's find out. Let's do the research. Let's do the experiment. Does a grape fall faster than a heavy rock that's the same size, or a chunk of iron that's the same size? Or does one fall faster? I don't know. Let's find out. And it's a simple experiment like that can lead to profound implications. Galileo did this. The fact that gravity pulls on all objects the same, they all fall at the same rate, is a profound idea, philosophically as well as scientifically, and it has implications for the entire universe. And you can do that by holding up a grape and a rock and dropping them together and seeing that they hit at the same time. Have them think about the question first and say, what do you expect? Do you expect the rock to hit first? Do you expect the grape to hit first? Have them write it down, think about it, and then do the experiment. And if it's wrong, go back and try to see where their thinking went wrong. Encourage them to think. Encourage them to ask questions. Have them look up things on the web. Ask them, does that make sense? Do you trust that website? Is it just somebody else who's making stuff up? Or does this person actually have the ability to understand this material and write about it clearly so that maybe you can trust them, or at least trust them provisionally, right? And then go to another website and see what they say about that person. This can lead to trouble. For every global warming site, you can find a global warming denial site. For every evolution site, you can find a creationism site. But who's got the evidence? Who's got the scientific backing to show what they're saying is correct? And there's going to be back and forth. Who's got the more convincing arguments? These are all steps that you can take to encourage kids to be scientists and skeptics. And the last part, I would say, since I've already run on very long here, the last part I would say is make it fun. Science is cool. Science is fun. When you look at a picture of a planet, it's gorgeous. It's so beautiful. You see Saturn with its rings and its moons. But you know what? There's more going on there. Oh, look, there's a storm on Saturn's atmosphere. Look how thin the rings are. Why is that? Well, I wrote about this in a post a couple of times. Why is this moon round and this one lumpy? Is it just size? Is it something else going on? Why is that? And you can show that there's a beauty just visually in science. Of course, when you look at these pictures, they're gorgeous, but there's a beauty in the knowledge of learning from them and saying, you know what, there's more going on here. When you break up the colors of the rainbow and understand why the rainbow exists, it doesn't detract from the beauty of it. When I look at a sunset and I see that the sun is getting squashed, sometimes you see the sun looking like it's getting squashed as it's setting and it turns red, I know why that happens. And it's cool. and it takes nothing away from the beauty. It adds to it. There's another dimension to the entire universe than just seeing something cool or hearing something cool. When you understand it, when there's knowledge behind it, that is power. That is, oh, I get it now. And that's cool. And then there's the next thing to learn and the next thing. And the beauty of science, and so one thing that kids don't always understand because they're always busy cataloging it, looking for definitions, looking for lists of things. It's not like that. It's a growing system. It's a process. There's always the next thing to learn. When you find out why that happens, it turns out, there's a little bit of a funny thing going on there. And there's the next thing to learn, and the next, and the next, and the next. There's no end to it, and that is so wonderful. There is nothing that inspires me more than knowing that there's always more to know. Okay, so, God, I just ramble on, don't I? I think I'm done. It's 20 after 2. It's been a little over an hour. So I'm going to wrap it up here. I'm sorry if I didn't get to all your questions because I just go on and on and on. But there you go. I'm just scrolling down the room here. Oh my word, there must be over 100 questions here. It's amazing. Thank you guys so much. Over 200 pluses. Thank you again. Thank you to the folks on Twitter. There weren't that many questions on Twitter, which is interesting. There you go. There's a piece of data, a piece of a datum that I can add to my knowledge and say, that's interesting. How can I get more Twitter people involved? And next time I'll remember to put the link in my blog. That's so embarrassing. And I'll try to get the time right. Again, this is live. It's all off the cuff, just trying to do this as I'm figuring it out. But I will be doing this more often. I really enjoy doing this, and I think this is going to be a lot of fun. So, to wrap up, just looking over my list. Okay, so, again, I'm going to try to do these on Sundays. That's a good day for me. I'm traveling a lot, and I'm doing a lot of stuff this year, so I'll announce them on Google Plus and on Twitter on the blog when I can. It won't always be Sunday. It may not be at the same time. So if you've circled me on Google Plus, you'll get those announcements. If you're on Google Plus and haven't circled me, please do. Registering for Google Plus is free. It takes a minute. It's actually a lot of fun. I'm following a lot of photographers, astronomers, political wonks, tech geeks. There's some celebrities. Jerry Ryan is a big science geek. I follow her on Google Plus. A lot of people like that. So it's a lot of fun. My website is badastronomy.com. If you go there, it'll take you to my blog, which is the Bad Astronomy blog, hosted by Discover Magazine. I'm on Twitter, Bad Astronomer. I'm on Facebook. Look me up. I don't know what the horrible URL is for Facebook. And Thursdays at 1800, and this is at 1800 UTC, Fraser Cain, Pamela Gay, and I, and a few other science journalists and scientists do the Astronomy Space Roundup for the week. We talk about the news that's happened, and we're going to be doing live telescope sessions as well. So you circle Fraser Cain, FRSERCIAN, and you'll get those announcements as well when we do those. The live telescope shows are very, very impressive, very cool. And we take questions from people there as well. I'm speaking at Pueblo, Colorado on Wednesday, January 25th. Monday, Tuesday, Wednesday, 3 days. Today's 22nd. Yes, I got that right. Yay. So if you're in the Pueblo, Colorado area, come see me. It's free. I'll be talking about myths and misconceptions about space, as well as saving the Earth from asteroid impacts. And I'll be at George Hrab's 21812 concert in Bethlehem, Pennsylvania on February 18th, 2012. That's in about 3 weeks. Very excited about that. I love George Hrab and Ms. Information, Donna, who helps him run everything. And I'll be seeing a lot of friends there, and that's going to be great. He's making a DVD of that concert, and it's going to be fantastic. So hope to see you all there. Hope to see you all online. Come to my blog, leave comments, send me notes on Google and Twitter, whatever. And I will talk to you all again soon. Thank you very much for showing up. Bye-bye.